So the topic or the lesson that we discussed last Monday was about the Marr's theory of perception. He proposed three different levels for understanding of information processing systems, and these are computational theory, representation, algorithm, and hardware implementation. So Marr attempted to develop a computational theory of vision in general. So he proposed that visual processing proceeds through a number of stages, and each corresponding to a different representation of objects, ranging from retinal images to 3D model representations. So computational theory defines a process purpose and provides an overview of how it can be realized in a concept. So this includes specifying the input and output as well as the constraints that will be utilized to compute one from the other. So the example is binocular stereopsis, wherein the input is the images of the left and right eyes, and the output is a depth map of features as seen from a point distance between these two eyes. So a constraint can be point in a picture corresponds to exactly one scene point.
In our topic last Monday, it said that Marr proposed three stages of understanding of information processing system, which are the computational theory, representation, and algorithm, and hardware implementation. And based on the case study, it focused in the computational theory, which is a precise specification of the function computed by the mechanism, or in the other words, what the mechanism does, and it aims to characterize the operation that produce this representation from the information included in the retinal image, as well as the elements of the external environment that are represented by the visual system. And based on what is stated in the case study, Marr believed that the goal of computation was to retrieve a general purpose description of the Euclidean space. This is the most evident in his conception of 2.5D sketch, which is, according to our last discussion, it was form of how surfaces in the view relate to one another and to those observer. According to Marr's theory, the purpose of early visual processing is to produce description of the environment in which the arrangement of the various surfaces is defined in relation to the observer's current view. We've been looking at ways to reconstruct the geometry of objects and surfaces from retinal image up until now. There is an insufficient information in the image to invert the process and recover a Euclidean description or space, which means vision is underdetermined.
The human version does not have or lacks an address-based geometrical representation of space, and the spatial representation process can be bypassed in certain dense contour arrangements. In human vision, the primary sketch is not automatic. A control mechanism sets the spatial scale at which spatial representation happens. The visual system finds and locates the basic features utilizing a variety of spatial filters such as lines, edges, corners, and intersections. The mechanisms by which the visual system combines the information from the various filters are designed to make the extreme spatial scales explicit and to use the largest scale to group the finer scales, resulting in a two-level hierarchy in which the spatial relations between different groups of features are represented in a Euclidean algorithm, but the elements within a group are only given an impoverished, possibly non-spatial representation.
So, earlier this week, we have discussed Marr's theory of perception, which we were able to tackle the three levels of this theory, namely computational, algorithmic, and the implementation of. In the case study of William H. Barron that has been provided to us, it revolved around the question of the effectiveness of Marr's computational theory in terms of solving the right or a certain problem. The significance of this case study to the topic that we have discussed previously is that this case study explained the complexity of solely the computational theory. It even stated that Marr's purpose of computational theory is to presume that the goal of vision is to recover or solve a general purpose Euclidean description of the world, which can be developed for any task, behavior, or action. The case study did not only explain the computational theory even more, but also the assumptions that can be pulled out of using the computational theory, including the unique correspondence matches, continuity or surface smoothness, surface rigidity, Lambertian reflectance, uniform texture size, and planar contour generators. From what I can understand, this case study solely is significant to our topic solely because it broadens the computational theory in a way that would make it more complex yet more understandable for the readers as well as the ones who will be testing this theory.